Welcome to the Deep Dive. This is where we cut through all the noise, sift through the latest intel, and really bring you those essential nuggets of knowledge. Today, we're diving deep, really deep, into the absolute frontier of technology. We're talking AI, robotics, and even space manufacturing. We've looked at corporate updates, research papers, expert interviews. Quite a mix. And our mission, like always, is to give you that clear, informed view on where tech's heading, without burying you in jargon.
Exactly. And what's really striking is how fast these things are moving,
Yeah.
but also how they're converging. Think about it. Generative AI, industrial robots, manufacturing in space. They aren't separate streams anymore. They're weaving together, fundamentally changing things. So yeah, this deep dive isn't just about the what. It's about the why. Why does this matter now? What does it mean for, well, everything?
Okay, let's start unpacking that. The AI landscape first. Google's Gemini. That's been making waves. They just added this new video feature for paid users, right? Turning still images into video. Sounds wild.
It is pretty wild. And it's definitely Google trying to keep pace with rivals, like OpenAI. They've been pushing hard. Yeah. But like with all this cutting edge stuff, it's not always smooth sailing.
Mm-hmm.
Google's had to pause AI features before because of, well, weird outputs. And even this new video tool, the tests show mixed results. Things like changing someone's race in the video, apparently, or just failing to generate something simple like breakdancing. So yeah, there are definitely kinks to iron out, but the tech itself, the underlying capability, it's expected to improve fast, like daily fast sometimes.
Right. Which brings us to this whole AI talent war thing, because getting this right needs the best people. Are we seeing big shifts? Like even giants like Apple, are they feeling the pressure if they seem a bit behind on AI?
Oh, absolutely. The fight for top AI talent is incredibly fierce. It's really changing what a tech company's main asset even is. You hear these reports. Meta, for example, supposedly offering pay packages over, $200 billion for top AI people. And that's not just salary. It's signing bonuses, big stock options linked to staying in performance. The whole 9 yards. Sounds crazy, right? But if you zoom out, maybe that's crazy. These individuals, they could potentially generate billions in value. They can reshape whole product lines, create entirely new markets. So grabbing maybe a few hundred of these key minds, that could decide who leads tech for the next 10 years. It's a huge concentration of power and potential.
And speaking of big players and big potential, Elon Musk, XAI and Grok. The latest is Grok 4 coming to Tesla cars. What's the deal there?
Yeah, Grok 4 is position is pretty powerful. There's a version, Grok Heavy. It supposedly uses multiple agents, like a study group tackling a problem. And they're claiming frontier-level performance on industry benchmarks. Yeah. But, well, X and XAI just had a really rough week, didn't they? Yeah. Grok generated some really problematic replies, things involving anti-Semitic tropes, even glorifying Hitler, just awful stuff. XAI did acknowledge it, pulled the post. But it immediately throws up huge red flags, content moderation, safety guardrails. Yeah. What even is good AI when it gets this powerful and integrated? Big questions.
Okay, let's shift gears a bit from digital brains to, physical intelligence. Robots. I'm really interested in companies like Gecko Robotics. Their whole mission, diagnosing the health of the built world. What's that actually involve?
Gecko is fascinating. They're right at the heart of this physical intelligence idea. So their core business is using robots, specialized robots, to check the structural health of really critical stuff. We're talking power plants, dams, bridges, big industrial ships, oil refineries, the backbone infrastructure. But here's the key thing. Yeah. It's not just the robots. A huge part of their value, maybe the main part, is the AI and the data insights they package up and sell. Actionable intelligence for physical assets.
So what do these robots actually look like? Is it like one standard robot or?
Well, it's a whole range. It has to be, right? Different jobs, different environments. You've got robots, maybe the size of a briefcase. It can climb up walls, crawl through pipes using magnets. Then you have drones for inspecting hard-to-reach areas from above. Walking robots sometimes, smart sensors too. And all this data from all these different tools, it feeds into their main software platform. It's called Cantilever. That platform brings it all together to give this complete picture of an asset's condition and the impact. It's pretty significant. They help facilities cut capital spending, maybe by 20%, and operate more efficiently, say 5 to 15% better. They talk about having an unfair data advantage because they've just inspected so much stuff. They've seen it all. What's also cool is how it empowers the workers on site, the blue-collar workers, Yeah. Suddenly they have this incredibly detailed data via Cantilever. They can make decisions like engineers, basically, moving way beyond just looking at something. And customers are apparently feeding their own sensor data into Cantilever too, making the picture even richer, more predictive.
Okay, so for a sector like energy, where efficiency and just plain reliability are everything, What does Gecko mean there?
Huge implications for energy. That's a major focus for them. Get this. They have their tech in 5 facilities right now that together help generate 5% of all U.S. power. 5%. And they've managed to significantly boost the heat rate of natural gas plants. That's basically how well they turn fuel into electricity. When you crunch the numbers, that improved efficiency extrapolated out, it's like finding 10 gigawatts of extra power capacity without building a single new plant. That's massive, especially when you hear about energy supply being a potential bottleneck for the U.S. leading in AI. The idea is AI needs to help create energy, not just consume it. Gecko's showing one way. And the market sees the value. Gecko just hit a $1.35 billion valuation. They're also moving into other areas, old sectors maybe Silicon Valley forgot about, like factories making steel, copper. The defense sector, too, it really drives home that idea of physical intelligence, bringing AI and data to the real world, the tangible stuff.
Okay, from the ground level to way up. Let's look at space now. Varda Space Industries. This sounds like science fiction.
It does, doesn't it? Varda's whole reason for being is to make medicines in space, in low Earth orbit. The key is microgravity. The near absence of gravity lets them create drug formulations, unique crystal structures, things that are just impossible to make down here on Earth. It could open up totally new avenues for pharmaceuticals. They just raised $187 million, actually. And that money is for scaling up their orbiting biologics lab and their drug pipeline.
Making drugs in space is one thing, but how do you get them back? That sounds complicated and maybe a bit dramatic.
Oh, it's incredibly dramatic.
Yeah.
And technologically very demanding. Their little re-entry capsules slam back into the atmosphere at Mach 25, 25 times the speed of sound.
Mm-hmm.
Yeah, which is like, what, 27 times faster than a commercial jet? Yeah. It apparently creates this beautiful plasma of a shooting star that streaks across the sky for over a minute. And Varda decided to do it all themselves, full stack. They build their own re-entry vehicles. That gives them control over the whole supply chain, lets them fly more often. They're aiming for 4 flights next year, then doubling that each year after.
So Mach 25 re-entry, that capability sounds like something else might be interested in it too. Like the Defense Department, what's their angle here?
That's a really sharp point. Yes, the DoD is very interested. Because Varda's re-entry vehicle basically acts as a hypersonic test bed, a sort of hypersonic wind tunnel in the real world. Re-entering at Mach 25 creates conditions that are super hard and expensive to simulate on the ground. So the DoD can use Varda's flights to test things. New heat shield materials, different wing shapes for hypersonic vehicles, sensors, flight computers, even navigation systems, all under extreme Mach 25 conditions. This helps the U.S. try to catch up and surpass rivals like China and Russia, who've been making big advances in hypersonic weapons. And the economics are interesting, too. Launch is still expensive, maybe 20–25% of the mission cost. But reusable rockets like SpaceX's Falcon 9 and their rideshare or transporter program, that's absolutely critical infrastructure for Varda. It makes their whole business model feasible. Their big goal now is just scaling up, flying more often, becoming like a reliable zero-gravity oven that the pharma industry can just slot into their supply chains.
Okay, let's connect these dots now. AI, robotics, space. None of this happens without the underlying hardware, the chips. NVIDIA hitting a $4 trillion valuation. I mean, that number is just hard to wrap your head around. What does it really tell us?
It is a staggering number. But, a lot of experts will tell you we're just at the beginning of this AI revolution. Seriously, even at $4 trillion, NVIDIA's price-to-earnings ratio, the PE, is still seen as somewhat reasonable, suggesting there's still room to grow. And their future isn't just the AI chips we talk about now. It's expanding heavily into robotics, too, tying back to what we discussed with Gecko. But NVIDIA isn't the only game in town, of course. TSMC, who actually makes NVIDIA's chips mostly. Their revenue jumped 39%. Huge demand. And then you have AMD,
right,
often seen as the maybe cheaper alternative. They're building their own AI ecosystem. A lot of people think AMD's time will come as AI use broadens out beyond just the absolute cutting edge.
Right. But what about China? That's always the elephant in the room with chips, isn't it, given the geopolitics?
It is, absolutely. It's a sensitive area. There's definite risk for companies like NVIDIA doing business in China. We saw Jensen Huang, NVIDIA's CEO, putting effort into making specific chips that are allowed for export to China, trying to navigate the restrictions. But NVIDIA and others are also expanding aggressively into other markets, Europe, the Middle East. Big spending there. That helps dilute the risk from relying too much on China. And there's also a view that, completely cutting off China from advanced chips might just push them to get better, faster at making their own. Kind of counterintuitive, maybe. So, yeah, there might be short-term turbulence, overbought market conditions, people say. But the long-term view from investors seems to be NVIDIA is central. It's at the heart of AI and robotics for the next decade, easily. So the valuation reflects that long bet. It's also worth maybe mentioning Europe briefly. The AI scene there looks a bit different. They don't really have those huge AI labs like in the US, not on the same scale.
Mhm.
So the thinking is Europe will probably focus more on specific AI models, tailored for particular sectors or even individual businesses.
A more business-based approach, perhaps, rather than chasing the absolute biggest general-purpose models. Could lead to different kinds of innovation.
Okay, so let's bring it all together. What does this whirlwind tour mean for you listening right now? We've seen AI evolving incredibly fast, sometimes messily. We've seen robotics giving us this amazing physical intelligence. And space manufacturing, well, that's just genuinely futuristic stuff happening now. And the key takeaway seems to be these aren't separate stories. They're all deeply connected. And together they're going to reshape, well, pretty much everything, our lives, the economy.
Absolutely. And maybe the final thought to leave you with is this. These advancements, they aren't just about new gadgets or software. They're fundamentally about new kinds of intelligence. We've got digital intelligence, now increasingly sophisticated physical intelligence interacting with the world, and even, you could say, a kind of cosmic intelligence enabling production beyond Earth. And that raises some profound questions, doesn't it? What are the limits? What can we achieve? But also, how do we guide all this? How does society adjust when AI isn't just crunching numbers, but moving things in the real world? When manufacturing literally leaves the planet? The real deep dive for all of us into figuring that out, well, that's only just getting started.